Hello, sanbonani, dumelang abseni wenda grade 10 mathematics learners. My name is Mr. K. Sedumedi. I'm here to discuss with you analytical geometry. But first, before we go into analytical geometry, I want us to look at the concept of Pythagoras theorem, and then we look at the Cartesian plane itself. How do we plot the points? How do we identify the points on a Cartesian plane? I think that will help us in engaging with analytical geometry. Now, before we start, I want you to pause the video. Make sure you are ready with your book, your pen, your pencil, eraser, so that whatever I talk about, you also write, because it's very important that you listen and write because you understand better. Pause the video, we'll take it from there. Okay, let us look at Pythagoras theorem. Now remember that we only apply Pythagoras theorem on a right-angled triangle. We are going to look at the right-angled triangle, and we are going to look at the two given sides so that we are able to look for the third side. Remember, Pythagoras theorem helps us to get the length of the third side when we are given two sides of the triangle. Now let us look at how we get the third side using Pythagoras theorem. Okay, let us look at Pythagoras theorem. Now, if you look at this triangle, it's triangle ABC. The question that I normally ask my learners is that, is this a right angle triangle? Most of them would say yes. But now, you need to be sure that it's a right angle triangle. How are you sure? It's when it's stated that triangle ABC is a right angle triangle. The other thing, they might not tell you, but they might put this sign to show that it's a right angle triangle. Now you can be sure that this is now a right angle triangle. The very same triangle as you look at triangle PQR is also a right angle triangle. Now I want us to apply Pythagoras theorem. We need to understand that there are three sides and there is the longest side. Which side is the longest side? The longest side, it is the side that is facing the 90-degree angle, that is opposite the 90-degree angle. It's always the longest side. The longest side on PQR, it is this one. If you can see, AC, it is the longest side. PR, in that triangle, it is the longest side. Now, when we apply Pythagoras theorem, we need to state that the longest side, when you square it, AC squared, AC squared must be equal to the sum of the squares of the other two sides. Which other two sides are we talking about? We're talking about AB. Remember, it needs to be squared, and also BC. So that is Pythagoras theorem. You can indicate that you are talking about Pythagoras theorem. Now, repeating that, the longest side should be AC squared. It must be equal to the sum of the squares of the other two sides. Or someone can write it as, okay, AB squared, those two sides, AB squared plus A plus BC, I'm sorry about that, plus BC squared must be equal to AC squared. I just started with the right hand side, then equal to the left hand side. It is the same thing. Now, Pythagoras say the longest side equals to the sum of the squares of the other two sides. Now, coming to this one, we can say PR, because it is the one that is facing the 90 degrees. PR squared is equals to the sum of the other two sides. What are the other two sides? PQ squared plus QR squared. Of course, you have to indicate that you're talking about the what? The Pythagoras theorem. So it's very important. Now I want you to pause the video and look at the other ones. I want you to look at these other three triangles and write the Pythagoras theorem as I did with the first two. You can pause the video and do that. Now, I hope this is what you have written. Look at this triangle MLN or LMN. It's up to you as long as you move around with that triangle. I hope you have written here that the longest side is LN or NL. It's fine. You write that LN squared equals to MN squared plus ML squared. ML squared. As long as you have the two sides, you can start by ML squared plus MN squared. It's still fine, but it is equals to the longest side squared. Coming to this one, which side is the longest? Of course, it's DE. You need to say DE squared equals DF squared plus EF squared. Someone can say EF squared plus DF squared. It's still fine. The last one, you look at the longest side. Which side is the longest? Of course, it is SV. Now, SV needs to be written as SV squared equals, I hope you can see that, SV squared equals to TS squared plus TV squared. Someone can say TV squared plus TS squared. It's still fine, but as long as you have your hypotenuse side. This side is called the hypotenuse side. The one that is facing the 90 degrees is called the hypotenuse side. Should be on that side. Now let's look at how we can be given two sides, and then we need to look for the third side. I'm going to move this page here so that I look at those exercises. Now, look at the first exercise. The unknown side is AC. AC is unknown. We need to look for AC because AB is 4 units, BC is 3 units. We need to look for AC. What is AC? It is the side that is facing the 90 degrees angle. Now we start with that side. We say AC squared is equal to AB squared plus BC squared. Of course, we're talking what? Pythagoras. This is the theorem of Pythagoras. Now, AC, do we have it? No, it is what we are looking for. We say AC squared equals to, now what is AB? It is 4. It is 4 squared plus, what is BC? 3 squared. And what is 4 squared? Never say 4 times 2. It is 4 times 4. Multiply 4 by itself twice, which will be equal to what? 16. 4 times 4 is 16. What is 3 squared? 3 times 3, 9. This equals AC squared. Now at the end, your AC squared becomes 16 plus 9, which is 25. Okay. Now because we are looking for the distance, AC squared is equals to 25. We find the square root both sides. What is the square root of A squared? AC squared is AC. And what is the square root of 25? It's actually 5. I hope you understand that. The second one. Now, which side is facing which side is the hypotenuse? The one that is facing 90 degrees. It is AC. Don't change. Apply Pythagoras. Pythagoras says, the theorem says AC squared is equal to AB squared plus BC squared. Now let us substitute. This is Pythagoras theorem. Pythagoras theorem. Now let us substitute. Do we have AC? Yes, we have it. It's 10 units. So we are going to say 10 squared is equal to, do we have AB? No. Leave it as AB squared plus, what is BC? BC is 8. So it's 8 squared. Now what is 10 squared? Remember what I said about 4 squared and 3 squared? 4 squared is 4 times 4. What is 10 times 10? It gives us 100, which is equals to AB squared plus, what is 8 times 8? 64. Now what is our target here? Our target is AB. We need to have our AB squared being equal to what? 100. Remember, now it becomes subtracted minus 64. And what is your AB squared? Your AB squared becomes now 36. Now finding the square root both sides, what will be the distance of AB? What is the square root of 36? It's 6. So your AB will be 6 units. Now let us look at, I'm going to ask you to pause the video so that you draw the two triangles and then try to answer these questions, and then we'll come with our answer after you have done them. So pause the video, try to solve these two questions on your own. Okay, I hope you are done now. Let us look at how you have tried to solve the unknown, for the unknown, which is this time RP. You are going to apply Pythagoras as we normally do. You are going to say RQ squared must be equal to RP squared plus PQ squared. Remember, don't forget the square. This is our famous guy, Pythagoras. Now, what is your RQ? Do you have the RQ? Yes, it's 25. 25 squared. Don't forget to square. Equals to RP squared plus, do you know PQ? Yes, it's 7 squared. Now, what is 25 times 25? 625. Equals to RP squared plus 49. Remember, now when it's like this, we need to subtract 49. 625 minus 49. That will give you your RP squared. Now what will be my RP squared? What is 625 minus 49? That should give you 576. That should give you 576. Now what is the square root of 576? That should give you 24. So that is how you get that one. Now let's go for the last one, which is D, whereby you need to find the unknown side, which is LM. Let's apply Pythagoras. LM squared equals MN squared plus LM squared. Famous guy. What is our famous? Who's our famous guy? Pythagoras. Now, what is Ln? Do we know Ln? Yes, our Ln is 25. 25 squared equals to, what is Mn? 15 squared plus unknown Lm squared. Now this should be 625 equals to 225 plus Lm squared. Now, what is 625 minus 225? You know the answer. I know you know it. Equals to Lm squared. Now, what is 625 minus 225? It's 400, which is Lm squared. And finally, the square root both sides. What is your Lm? What do you think the size of Lm? 20. That is 20 units. So that is how you get the unknown side using Pythagoras theorem. Right, we have looked at how we find the third side on a right angle triangle using Pythagoras theorem. Now I want us to look at the same right angle triangle, how we get the third side now on a Cartesian plane. First, let us look at how we plot the points, or we identify the points on a Cartesian plane. Now the Cartesian plane, it's normally called the XY plane. It's also called the XY plane. Why do we call it the XY plane? Because any point on this Cartesian plane needs us to identify the value of X and the value of Y. That's why it's called the XY plane. Now, I want us to look at how we identify points on a Cartesian plane. Now, the very first point, right here where the two lines intersect, it's called the origin. That point, origin, is 0, 0. The point is 0, 0. Let me just note it here that the point here is what? 0, 0. Now that's where everything starts, where you start moving from the origin. It's called the origin. Now, once I identify the X value of any point, I need to identify whether I've moved to the left or to the right, because right here it's 0. The value of X is 0. If I move 1, 2, 3, 4, 5, you look at this point, I have moved 5 units to the right. It means the value of X is 5, and I move 1 unit up, meaning that the value of Y is 1. So this point, let us call it A. We can say it's the value of X is 5. And what is the value of Y? The value of Y is it's 1, because that is the point right there. Now, if you look at another point, I can choose a point here. I can call it B. Now, if you look at that point B, have you moved to the left or to the right in terms of X? Because X value is moving to the left and to the right. No, I haven't moved to the right or to the left. So my X value is 0. What about my Y value? I have moved up. How many units? 3. So that point is 0, 3. Now, look at this point here. I can call it C. Look at this point. I can call it C. What do you think is this point? Have I moved from the origin to the right, to the left? Yes, I've moved. How many units? 4 units. Now, what is the value of X here at this point? It is -4. Have I moved up or down? No, I only moved to the right. So the Y value is 0. So as you can see, on top of the X axis, this line, my Y is 0. What about on top of the Y line? My X is 0. My X is 0 on top of the Y line. On top of the X line, my Y is 0. Okay, let us now identify these following points on the very same Cartesian plane. I'm going to find the first one, then you'll find the rest. Now the first point is P -5, 2. Remember, the -5 is the value of X and the 2 is the value of Y. Now let us look at where X is -5, it's right there, and then where Y is 2, move up 2 units. So there will be my point. And what is that point? It is P, I must label it P -5, 2. So I want you to take 1 minute to identify these other points. Just take a minute to identify these other 4 points. Okay, I hope you have identified the points. The second point was BR3 -3. X is 3, Y is -3. So we're looking at X being 3, Y being -3. And there's your point R. So we must label it as R3 -3. The next point is n0, -4. 0, negative. Remember, x is 0, so it means it's on this line. And what is 0, -4? There is the point. That point is identified as n0, -4. And then the next one is m50. Remember, x is 5 and y is 0, so it's on top of this line where y is 0. So we put here this point as your m. I'm going to write it here, 50. It is that point, m50. And lastly, a point is s72. S72. X is 7, y is 2. There's where x is 7, but I need to move 2 more units up for y value. Now that point, the point here is S72. So that's how you get the points on a Cartesian plane. Right, we have identified the points on a Cartesian plane. Now I want us to look at how we can get the distance of a line between 2 points. It's very helpful. Now you'll understand why we're doing Pythagoras theorem, why we're doing the points on a Cartesian plane. Now I want us to find the distance, the formula for the distance between 2 points, the line between 2 points, a straight line between 2 points. So we need to see how we get that formula so that you understand the formula and know how to use it. Let's find the distance. Okay, I want us to look at now the right angle triangle on a Cartesian plane so that we understand the distance formula correctly. Now if you look at a right angle, the triangle has got the coordinates A, B and C. Let us identify these coordinates. The first one, if you look at the first point, your x is 3, your y is 1. I can write 3, 1. And then if you look at point B, I'm looking at the x value being 7, the y value being 4. So I'm going to write 7, 4, and I'm going to find the coordinates of C. I can see it's still 7, the x value is still 7. Then this is 7. Now what about the y value? The y value is 1. Now if you can look at this as a right angle triangle, you can see that BC is a vertical line because the x value doesn't change. And then if you look at AC, it's a horizontal line because the y value does not change. It is horizontal. But now what changes is 3, 7. Now I want us to identify the distance of AC. Look at the point A, look at the point C. What do you think is the distance of AC? Let us see. It's from 3, we move 1, 2, 3, 4. So it means AC should give us 4 units because it's the distance between 3 and 7. This should give us 4 units. And then if you look at the distance of BC, since it's a vertical line, you can see now it's from 1 to 4. The y value from 1 to 4. So it means it's how many units? 1, 2, 3. It's 3 units. Now if it's 3 units, is it possible for us to get the distance of AB? Now let's go back to AC. Do you see that AC is 4 units? Can you find the easier way of getting the distance of 4 units? You can simply say 7 minus 3. It can be written as 7 minus 3. So the higher value of x minus the lower value of x, which is 7 minus 3, which is 4. You can see that. And then how did you get these 3 units? It is 4 minus 1. You can say, oh, this is the same as 4 minus 1, which gave us the 3. Do you understand that? Now, can we find AB? Yes, we can find AB using what? Pythagoras theorem. Let's write it. AB squared is equals to the other two sides. It is 4 squared plus 3 squared. I want you to find, I want us to look at how did you get the 4 here and how did you get the 3 here. How did you get the 4? It is 7 minus 3, that is squared, plus, how did you get the 3? It is 4 minus 1, so it is the same as 4 minus 1, which is squared. Now that gives us a b squared. Do you see that? Now if you look at this 7 minus 3, this is the first x value, this is x1, this is the second, the 7, it is the second x value, we can write it as x2. Now if you look at 1 and 4, this is the first y value, this is our y1, which is our 1, and this one, it is our second y value, which is y2. Now if I put it, substitute here, this will be a b squared is equals to, what is my 7 here is x2 minus the first x value all squared, plus, what about that one, 4, it is my y2 minus y1 all squared. So remember, this is 7 minus 3, which was 4. This is 4 minus 1, which was 3. That's why we say x2 minus x1, y2 minus y1 squared. Therefore, now we know that for any distance AB squared, it should be equal to x2 minus x1 all squared plus y2 minus y1 all squared. Somebody can write it as, I'm going to find the square root both sides, AB, square root of AB squared is AB, is equals to the square root of what? X2 minus x1 all squared plus y2 minus y1 all squared. That is the formula for distance between 2 points. Now I want us to look at the 2 exercises. The first exercise actually, which says we must find the distance between 2 points. Let's find the first one, A, which says we must find the distance between A minus 3, 1 and B 1, 2. I normally advise people to say, oh, this is my x1, y1, this is my x2, y2, so that it becomes more simpler for you when you calculate the distance. Then you'll say, okay, in that case, AB must be equal to the square root. Remember the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now, how do you get the distance? This will be the square root. You can now substitute. It's easy now because you have mentioned your x1, y1, your x2, y2. So this will be 1. Remember, my x2 is 1. Subtract what? Like I'm saying, my x2 is 1. Subtracting my x1, which is negative 3, that should be squared, plus, now we come into the y values. What is my y2? It's 2. That will be 2 subtracting y1. What is y1? It's 1. You must square that. This will ultimately come to the square root of, now look at this, 1 negative times negative positive It's 1 plus 3, which is 4. And what is 4 squared? It's 16. 4 times 4. This is 16. And then what is 2 minus 1? It's 1. And 1 squared is 1. So what is 16 plus 1? 16 plus 1 is 17. So you leave it as it is. It is a simplified set form because you cannot break it down further. So this is the square root of 17. So I'm going to take a minute or two so that you do the next 2 questions, whereby you need to calculate the distance, PQ and RT. Just copy the questions and then pause the video and then start doing those questions. We will do the remedial after this. Okay, let's see how you have solved those 2 questions. Now we're going to look for the distance of PQ. Now PQ, remember the formula, x2 minus x1 whole squared plus y2 minus y1 whole squared. Now this will come to the square root of what? What is my x2? Remember, I need to remind myself this is x1, y1, x2, y2. So what is x2? It is 8. Now we're talking 8 minus 0 whole squared plus negative 1, which is y2, minus 1 subtracting 5. Remember, everything should be under the square root sign. This should be the square root of. Now look at this. 8 minus 0 is 8. And what is 8 squared? 64. Then what is 1 minus 1 minus 5? It is minus 6. Minus 6 squared is 36. So we have 64 plus 36, which is 100. Now what is the square root of 100? The square root of 100 will be 10. So the distance of PQ is 10. I hope you got that correct. Let us go to C. Must be careful with the signs. We are going to look for what? RT. We still use the same formula. RT square root, don't mind my square root sign, x2 minus x1 all squared plus y2 minus y1 all squared. Right? Now I'm going back there to the question, say, oh, by the way, you are my x1, you are my y1. This should be my x2 and my y2. So when I substitute now, it becomes easy because now I'm saying my x2 is what? 1. This will be the square root 1 minus what? Negative 3. It is 1 minus negative 3. It's 1 minus negative 3 all squared plus. What is my y2? Negative 3 minus 3. Subtracting what? Subtracting a 1. You square that. Now what will you have? The square root of what? 1 minus negative 3. Now remember, now this is negative times negative, which is positive, which is 1 plus 3, which is 4. 4 squared, 16. And minus 3 and minus 1, minus 4. Minus 4 squared is 16. So you have 16 and 16. What is 16 plus 16? 32. You can press your calculator. This will give you 16 times 2. The square root of 16 is 4. So it is 4 square root 2. So that's how you get the distance of a line between 2 points using the formula, the distance formula. Right, we have found the formula for the distance. We've calculated the distance. I want us to look at how do we find the midpoint of a line between 2 points. That midpoint of a straight line, it's very important that we know the midpoint. Now let's see how we find the midpoint of a line between 2 points. Right, About a midpoint of a line, let's consider the line between A and B. That line between A and B. How can we get the midpoint? The midpoint is halfway through the line. Now let's look at the number of units this line is. It's 1, 2, 3, 4, 5, 6. From 2 to 8 it's 6 units. From 2 to 8. Now it means if I go 4 units, I'm halfway, meaning I go 1, 2, 3. Now because it's 6 units, it's 1, 2, 3, 4, 5, 6. So it should be 3 units. Sorry about that. It is 1, 2, 3. So at 5, that's where I'll get the midpoint. Do you understand? Therefore now it means halfway through the line, it should be this point. Now what do you think is this point here? What is the value of x? The value of x is what? It's 5. And the value of y is still 1. It hasn't changed. Can you see that? So that midpoint is 5, 1. Now there is a way of getting the midpoint on a line. If you look at the x value of a is 2 and that one is 8. So if I say 2 plus 8 and that total, dividing it by 2, because I'm looking at halfway, dividing by 2, and I do the same with the y value, I have 1, and adding it with that 1, halfway, divide by 2. What point will I get here? I'm going to get 2 plus 8, which is 10, and 10 divided by 2 is 5. And what is 1 plus 1? It's 2. 2 divided by 2 is 1, which is exactly the same point that I'm talking about. Therefore, the coordinates of the midpoint, M, it's actually x1 plus x2 divided by 2 together with y1 plus y2 dividing by 2, which is what I've done here. Therefore the midpoint is x1 plus x2 divided by 2. You add also y1 and y2 divided by 2. So I'm going to look at the exercise that will need us to solve. Look at exercise 2, where it says find the midpoint of a line between these points. Now look at the first one, it's A. Let us look at A, where A says A, the midpoint, we have A being what? 3, 0, and also B, which is what? 1, 4, which is 1, 4. So if I calculate the midpoint, the coordinates of the midpoint M will be what? X1 plus x2. It will be 3 plus 1. Remember, you need to divide by 2 halfway, and then the other one, the y value, is 0 plus 4 divided by 2. And what are the coordinates of M? It's 3 plus 1, which is 4. 4 divided by 2 is 2. Then 0 plus 4 is 4. 4 divided by 2 is 2. So that's how you get the midpoint. So you need to do B and C. Pause the video, do B and C, so that you get those coordinates of the midpoints. Okay, let us look at now the midpoints on B, the midpoint of C, of a line between C and D. Now, midpoint, don't put the equal to sign, just say the midpoint Then show that you add the x value, minus 3 plus 1 over 2. And at the same time you add the y values, 4 plus 6 all over 2. Then your coordinates of the midpoint M will be negative 3 plus 1, which is negative 2. Divide by 2, it's negative 1. And then we have 4 plus 6, which is 10. 10 divided by 2 is 5. So that is the midpoint of a line between C and D. As you go to the last one, C, we have P, which is 0, negative 7. And then we also have Q, 3, 3. Easy stuff. Then you go to the midpoint. Your midpoint will give you 0 plus 3. 0 plus 3. Make sure you substitute correctly. All over 2. And the other value is negative 7 plus 3. That will be divided by 2. Therefore, ultimately your midpoint will be 0 plus 3 is 3. Therefore, it will be 3 over 2. And then the y value is negative 7 plus 3, which is negative 4, divided by 2 is negative 2. So easy stuff. That's how you get your midpoint. Now, we have looked at the distance of a line between 2 points, and we have calculated using the formula. We have also looked at the midpoint of a line between 2 points. So it is the distance, the midpoint. I now want us to look at the steepness, which is called the gradient. The gradient of a line between 2 points. It is the steepness. The steepness tells whether the line is increasing, it is horizontal, it is decreasing, or it is vertical. Now that will depend on the gradient itself. So you are going to get the formula of how to calculate the gradient. Right, let us look at the gradient of a line. Remember the gradient, I explained earlier that the gradient is the steepness. Now if you look at these straight lines, they are different because in a sense that they are different in the sense of their steepness. Their steepness is different. The first line is increasing. How do you see that it's increasing? You must move from left to right. Moving from left to right always, it will tell you whether the line is increasing, decreasing, horizontal or vertical. Now the second line, as you can look at it, it's horizontal. And the third one, this one is decreasing. How do you see that it's decreasing? I said you must always move from left to right. You will see that it's decreasing. Obviously the last line, it is vertical. Now the symbol for gradient, we use the small letter M. It indicates the gradient. Now when you see an increasing line, you must know that the gradient is greater than 0. What is greater than 0? It's positive. The gradient is positive. So once you get a value that is greater than 0, a value that is positive, you must know that the line is increasing. When the line is horizontal, expect the gradient to be 0. When the line is decreasing, expect your gradient to be less than 0, meaning it's negative. Because you know, even if when you go down the step, go downstairs, you don't need any energy. So gradient is negative. But now once the line is vertical, the gradient is undefined. The gradient is undefined because now it is vertical. So that's how you must know about the gradient of lines. Now, how do you get the formula to calculate the gradient? We're still involved with x1, x2, y1, and y2. Now, a gradient of a line between 2 points, you indicate it as m, small letter m being equal to the y values first. y2 minus y1 divided by x2 minus x1. That will give you the thickness. Please don't put your x2 and the x1 on the numerator. They must be the denominator. The y2 and the y1 must be the numerator. Now, as I look at one exercise that I've noted here, that I've indicated that you have to calculate the gradient of a line between 2 points. Now let us look at the gradient of a line between. I want to make this clear for everyone. Let us look at the gradient of a line between A being minus 3, 4 and B 2, 1. I'm going to write it down. I need some space here. I just want clarity here. Okay, I think it's clear now. I'm going to look at your A, our A being negative 3, 4, and our B being 2, 1. 2, 1. So how do you get the gradient? The gradient M is equals to y2 minus y1 over x2 minus x1. So how do you get that? Substitute. You can still do the x1, y1, x2, y2. What is my y2? Is 1. It is 1 subtracting what? 4. y2 minus y1 is 1 subtracting 4 dividing by, what is my x values? Is 2 minus negative 3. Must not make a mistake there. 2 minus negative 3. This will be equal to, what is 1 minus 4? That will be negative 3. So that will be negative 3 dividing 2 minus negative, and negative times negative is positive, and what is 2 plus 3 is 5. Therefore your gradient will be negative 3 over 5. So I'm going to give you 2 minutes to do B and C. Pause the video and then do B and C, and then we'll come back and solve that one. Okay, let's see how you have done your B and C. You were supposed to find the gradient of a line between P and Q. Let's find the gradient. Let's see if you have done it correctly. This will be equal to y2 minus y1 dividing x2 minus x1. This will be equal to the y values first, 3 minus 1, 3 minus 1 dividing, then the x values, 7 minus 5, 7 minus 5. So what do we get here? 3 minus 1 is 2, and then 7 minus 5 is 2. So at the ultimate end, the gradient is what? 1. The gradient will give you 1. I want us to discuss these gradients when we finish. Now, C, your gradient as being y2 minus y1 over x2 minus x1. So this will give us 4 minus 2. 4 subtract negative 2 dividing 0 subtract negative 3. So what do we have here? We'll have 4 plus 2, which is 6, 0 plus 3, which is 3. So we are going to get 6 over 3, which is how much? The gradient will ultimately become 2. Now look at the answer for A, B, and C. According to the answer in A, can you tell whether the line is increasing or decreasing? obviously it is decreasing because the answer is negative. And then for B, because we got the answer as 1, 1 is positive, the line is increasing. And C, we got 2 as the answer, the line is increasing also. Sometimes you'll get undefined, sometimes you'll get 0. You'll be able to tell if it's 0, it is horizontal, and if it's undefined, it is vertical. So that you'll be able to see that. I hope you understand about the gradient. Grade 10 learners, I hope you have understood the concept of analytical geometry, which involves the distance between 2 points, the midpoint of a line between 2 points, and also the gradient, which is called the steepness. Till we meet again, ciao!